Hello everyone, welcome to your pre-lesson video today on measurement, area, and volume. We have quite a lot to cover today, so let's get started. So first thing that we're going to go over is area of rectangles and squares. So you probably have come across this many times over your years of doing math. Well, we're just going to recap really quickly how to find the area of a rectangle and a square. Alright, so as you can see, the area of the rectangle would be the length, which is normally the longer side, times the width, which is the shorter side. Okay, so length times width will give you the area, and that's for a rectangle. Now for the area of a square, because if you remember, squares have the same length on each side. So you're just going to do S, which is side, square, right? So if your side length is 1, it's just going to be 1 square. If your side length is 3, then it'll be 3 square, which means you have 9 square units. Alright, so for squares, just square the number. Now, for area of parallelogram, this is how you would find its area. So you're going to take the base, which is this longer side here, alright, not the slanted side, longer side, times the height. So the height would just be anywhere along the parallelogram. Not here though. It has to be at least from this corner to here and anywhere around here. Alright? So base times height would equal the area for the parallelogram. Oh, and one thing I want to remind you all before I completely forget is that on the SAT, they do give you a list of formulas for certain shapes for the area and volume of it. But for the ACT, they do not. They might mention it, but don't hope on that, right? But in any case, for both the ACT and the SAT, I would strongly encourage you to memorize all of the formulas, because one, that will save you time. Two, in case they don't give you, then you're not going to be in that much trouble. Alright, so best if you can memorize all of these formulas for the areas and volumes of the shapes. Alright, continuing on, the next thing that we have is area of a triangle. Okay, so to find the area of a triangle, we're going to take half times base, which is the bottom here, times height. Alright, and this is for a right triangle. So right angle will be here. So we wouldn't take the side, right? So we wouldn't take this side or this side for the base. The base will be right across the 90 degrees. So here's the base times height times half, and that's to find the area of the triangle. Now, let's say you weren't given the base, but you're given an isosceles triangle instead. What you could do to find the area is take half times s squared, so side square, because these two should be the same length if it's an isosceles triangle, times sine theta, which is whatever angle you're given. Alright, so this one very rarely comes out, and even if they do, they normally actually do give you the formula for this, but it's good to know. This is the more common one. This is the one I definitely encourage you to remember. Alright, so A equals half times B times H for the area of a triangle. Alright, next thing that we have is area of trapezoids and rhombuses. Alright, so for the area of trapezoid, we would first need to do base 1 plus base 2, divide that by half, so B1 plus B2 divided by 2 times H. Alright, and that's to find the area of the trapezoid. So this plus this, get that, divided by 2 times H. Alright. For rhombus, we would take the diameter, not diameter, but this distance 1 times distance 2 divided by 2 to find the area of a rhombus. Alright, so I would definitely encourage you to at least memorize the rhombus one, because that is the one that does not come out on the test. Trapezoid may or may not, but again, like I said before, it's best if you can just memorize all of the formulas in case they do not give you on the test for both the ACT or the SAT. Okay. Now for the area and circumference of circles. So if you remember in our previous lesson, circumference essentially is the perimeter of a circle, and it has a special formula for it. So to find the circumference of a circle, you're going to use either 2 pi r or pi d. Now, the reason why you could use either one of this is because if you remember, diameter is double of radius. So 2 radius would equal to a diameter. Hence why 2r, so 2 times r would equal a diameter. That's why you could either use 2 pi r or pi d to find the circumference of a circle. So remember, circumference is the entire thing. This is diameter. All right, and then this is the radius, half of it. Now to find the arc length, so not the entire circumference, but part of it, so the arc length of a circle, you would need to do, you do actually need to use 2 pi r, or you could also just use pi d for this case. But to find a specific arc length, you're going to take the theta, the angle that you're given, divided by 360, right? Because you want to find the fraction of the circle that you are wanting to find, right? And we know that the entire circle has a total angle of 360, which is why you're going to take the part that you're given, so theta, divided by 360 times 2 pi r or times 2 pi r or pi d, right? And that's to find the circumference and arc length of a circle. Now to find the area of a circle, you must use pi r square. You cannot use the diameter to find the area or the area of a circle or its sector. You have to use radius. All right. So if it gives you a diameter, you got to find a radius. So for area of circle, the formula is pi r square, right? And one thing to also preface is that, remember, pi is a specific value. If you can find it in your calculator, great. Just put pi in your calculator and it should calculate for you. Or if you're not too sure, you can always just put as 3.142 as your value of pi. Or if they say in the question, use pi as 3.14, then use that. All right. Sometimes maybe the question doesn't even, if you look at your answer options, right, for your questions, maybe it gives you like 3 pi, 4 pi. That means you're just going to leave the answer in terms of pi. You're not actually going to put the value of pi in your calculator. All right. So we'll actually see how to do all that during your deep dive lesson. All right. Now that's for area of circle. We're going to use pi r square. Now for area of sector, again, it is very similar to your arc length. We are going to use pi r squared times the fraction of the circle that we are given. So we're going to take theta, which is the part of the circle that we're trying to find, the area for, divided by 360 because that is the entire angle of the circle. So theta over 360 times pi r squared. All right, and that's to find the area of a sector. Now, for perimeter, just a quick recap. So the perimeter, remember, is the total length of the sides of any enclosed shape, right? So it'll be this length right over here. So as you can see here, the total boundary distance is what we would call the perimeter. Now there is a difference between area and perimeter, right? So area essentially is the space inside the lines, whereas perimeter is the total length outside of the lines. And then area is found by multiplying the numbers, whereas perimeter is found by adding. All right. And then area is normally given in square units like centimeter square, inch square, mile square, meter square, whereas perimeter is given in just units, which is like centimeter, inch, mile, meter, and that's all. All right. Alrighties. Now the next thing that we have is classifying three-dimensional figures. So essentially a three-dimensional figure or a 3D shape, 3D figure is a geometric shape whose vertices lie on more than one plane. So normally it's on the X, Y, and Z plane. All right. So the flat surfaces of a 3D figure, like this one here, is called a face. The segments formed by intersecting faces are called edges. So like this is an edge, this is an edge, this is an edge, and this is an edge, and so on. All right. And then the points formed by intersecting edges are called vertices, or your corners, essentially. But the more geometrical term for here is vertices. So I'm just going to refer to that. All right. So again, this is your vertex, 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 vertex. All right. And so here is a really helpful chart to see like how many faces, edges, and vertices each of these 3D figures have. You don't have to memorize it. You can always, just count it on your own during the test if they ask you how many faces, edges, or vertices are in a 3D shape. All right. Now, some of the common 3D shapes that do come out during your test are these. So a prism, right? So a prism are solids with identical polygon ends, as you can see, and flat parallelogram sides. So we have this is called a square prism because this is a square, triangular prism because this is a triangle, and a pentagonal prism because this is a pentagon, right? And a cube and a cuboid would also be considered prisms, actually. So these are just really helpful to identify what kind of shape they are. The next thing that we have is a pyramid. So a pyramid, which is a polyhedron, and if you remember, poly means many, hedron means faces, so many faces, right? So a pyramid is a polyhedron with a polygon base, and an apex, which is the tip of the top there. So these are what we call the apex, with straight edges and flat faces. All right. So this is what we call a square pyramid because the base is a square. Triangular pyramid because the base is a triangle. Hexagonal pyramid, as you can see, hexagon base. Pentagonal pyramid because pentagon base. All right. So this is really good to identify because you will be needing to know what kind of base they are in order to find its surface area and volume. All right, and we'll get to that in a bit. Next thing that we have is a cylinder. So, all right, so a cylinder has two circular faces at the top and the bottom, and a curved surface, as you can see here. So take like your tin can. That will be what we call a cylinder because it has two circular faces and a curved surface, right? And its height is perpendicular between the top and bottom faces. All right, and then as you can see here, from the center of the circle to its edge will be the radius. Okay. Now a cone has a flat circular base. All cones do have a flat circular base, a curved surface, as you can see, and a pointed tip at the top, which again we call the apex. So it's like your ice cream cone, right? The top where you put the ice cream, if you can imagine it closed, will be your flat circular base. Then the thing that you hold on to will be the curved surface, and then the very bottom will be the apex. All right. So with a cone, from the apex, if you drop it perpendicular to the circular base, we would have our height. All right. And then from here, from the center of the So essentially from the apex of the cone to the center of the circular base, we would have our height, okay? Because it will be perpendicular. Now from the center of the circular base to its edge will be the radius. Then if you can see, 90 degrees, so it would form along the curved surface its length. We can actually find what the length is based on Pythagorean theorem because it is a right angle, right? So leg, hypotenuse. We may or may not see that during your deep dive lesson, but just keep in mind that that's how you can, one thing that you could possibly find. All right, the next thing that we have is a sphere, right? So sphere, as you can see, it's round in shape. This is just in 3D and has all the points on its surface that are equidistant from its center. There we go. All right, so from anywhere, from the center here to any point of the sphere, they're going to be of equal distance, okay? And so as you can see, as usual, we can still find the radius and the diameter of a sphere because it is a circle in essence, okay? Now, surface area. So the surface area is the sum of the areas of all the faces of the 3D figure, right? And so these are the formulas that you would need to memorize because the ACT and SAT do not give this. You do actually need to memorize this one. Luckily, not many questions come out on surface area, but it is really handy to memorize these formulas. And I'm just going to put it out there for you. You have it in your pre-lesson packet. but I'm not going to go over this. You can just look over it by yourself. All right. And if you have any questions about surface area, send me a message, an email, or bring it to your deep dive lesson. And we will actually go over 1 or 2 questions during your deep dive lesson on how to find surface area. But this is it for it. All right. Now, onto the more major part is volume of 3D figures, because this is the one that they do ask a lot more common about on both the ACT and the SAT tests. So first thing that we have is volume of prisms and pyramids. So for prisms, which includes, the cubes and cuboids, we would use the base area. So we do need to find the area of the base times the height. All right, so find the base. So if it's like a square base, find the area of the square times the height. If it's a triangular base, find the area of the triangle and then multiply the height. All right, so that's for all prisms. Next thing that we have is volume of pyramid. So for volume of pyramid, its formula is going to be 1/3 times base area times height. So again, you do need to identify what kind of base it has. So like this one, it's a triangular base. So I need to find the area of the triangle first, right? Once I find the area of the triangle, I'm going to multiply it by the height and 1/3 to find the volume of the pyramid. Same thing for this. I need to identify the base. This is a square base, so I need to find the area of the square first and then multiply it by the height and then times 1/3. Same thing for this one. As you can see, it is a hexagonal base, so I need to find the area of the hexagon first. And once I find the area of the hexagon, I am going to multiply it by the height times 1/3. And that's how you find the volume of the pyramid. All right. Now for volume of cylinder, we are given by this formula, which is pi r squared, right? Because that is the surface area of the circle times h. It's pretty simple. If you have a circular base, you're just going to do pi r squared times the height. All right. So I'm just going to jump ahead to volume of cone first. So as you can see, volume of cone and volume of cylinder is very similar. They both have pi r squared h. Now for cone, you're just going to multiply an extra thing, which is 1/3 to find the volume of cone. Right? So again, base area, pi r squared h. Base area is pi r squared times h times 1/3. Because if you were to actually visualize it, if you were to put another cone here and another cone here, it would actually give you a cylinder, which is why the volume of a cone is 1/3 times pi r squared h. All right? Now, for volume of sphere, it's a little bit different. For sphere, we would need to do 4/3 pi r cubed. Alright, so this one for sphere, it's a no-brainer. You just have to memorize this formula. 4/3 pi r cubed to find the volume of sphere. Alright? And that will be it. These are all of the formulas for the area, surface area, and volume for your 2D and 3D figures. All right. If you have any questions, I know it's a lot of formulas that you do need to start remembering. If you do have any questions, as usual, send me an email or bring it to your deep dive lesson. All right. Thanks for tuning in and have a good rest of your day. Bye.